I'm very happy to be here, frankly. I grew up in Delhi. My first 25 years of life was in Delhi. So if anybody is local or anybody from outside, you need tips about where do you get the best food. And I grew up in Chandni Chowk, so that's my home. So if anybody needs tips, I'm happy to share. So it's quite a pride and an honor for me to be standing up on the stage and talking about how cloud native and AI work better together. I'm also on the CNCF governing board. I'm the governing board chair as well. So if you have any questions around CNCF in general, how we can do better, I'm always looking for suggestions. So let's talk about why cloud native and AI better together. This theme is actually inspired by a book that was written by Cassandra Chin, FIPI and AI, and she wrote a beautiful book for getting kids started, leveraging cloud native and AI. So we just borrowed that theme from there. Cloud native, over the years, over 10 years, has always adapted, right? We started with stateless. That was the initial theme. Then we got on to stateful, then serverless, and now AI. Over the years, the workload, the patterns have always emerged, and cloud native, as Aparna was talking about, is the tried and tested platform. It has always evolved. In a very classical CNCF manner, a new working group was started when the AI became the norm. So there's the Cloud Native AI Working Group, which is part of TAG Runtime, which is essentially, the whole mission is really, how do you streamline the integration of AI and cloud native ecosystems? New workloads are coming in, what new efforts need to start, what new projects need to happen, identify the end user requirements. What do end users want? We have been cloud native. As AI workloads are coming in, what do we need to do to serve them better? Engage with the right set of communities. Now, whether it's on the Linux Foundation side or non-Linux Foundation side, because AI is literally happening everywhere. So that collaboration with community entities is super important. And end of the day, this is basically a deliverable where we create content like white papers, guidance, best practices, tools, and evangelism in general sense that how cloud native and AI work very well with each other. So one of the deliverables so far of the working group has been the Cloud Native AI white paper. And the white paper really talks about, it's a long paper, but it talks about cloud native, AI, and how they work with each other. And the way white paper is written is you can see exactly, I'm a cloud native person, I don't need to read about cloud native, I'm going to jump to the AI section. Or I'm an AI person, or I'm going to just jump to the cloud native and AI integration part of it. It talks about AI playground. It talks about reference architectures that could potentially be created. So really a useful read if you want to get started on this journey. I believe cloud native is the ideal platform for AI. And this is some of the reasons what you always expect out of your any platform, essentially, of any workload that is running on top of it. Cost efficiency is important. When you're running a platform, you already have an existing investment. Should you make a new investment in a new platform? How do you make it cost efficient? Scalability is important. Training is a kind of workload when you're doing from the AI side of it. It could run for weeks, months, but inference is more bursty. So how do you scale up as your app is scaling up? Containerization is super important, but that really makes you independent of the underlying compute, wherever you want to run it. Harmony, which is between your dev, test, staging, and production is super important. Kubernetes gives you that basic compute layer. Once you have that up and running, then everything kind of sits on top of it. I could do kind on my desktop. I can do some Kubernetes cluster on my dev environment or staging environment and use a managed service. Just as long as it is upstream compatible, it works very well. High availability is one of those declarative aspects of Kubernetes which you get by out of the box. And then finally, the microservices architecture is super important because you can't create a monolith and expect it to scale. Monoliths work very well, but breaking this apart works really well. And these are all the basic primitives of cloud native, which is what makes it as an ideal platform for AI. Let me take you on a journey from cloud native AI perspective from 3 different personas: Kubernetes perspective, ML engineer perspective, and then finally the app developer perspective. Let's take a look at it from the Kubernetes perspective. One of the fundamental changes we did in Kubernetes is DRA, or dynamic resource allocation. And what that gives you is the ability, a new API on how you can access the resources in the backend. Up until now, if you were to access a GPU, you would say in your Kubernetes manifest something like nvidia.com/GPU:2. And that's the only granularity that you had available. With this dynamic resource allocation, it gives you a much richer API for requesting and configuring resources. When you're bootstrapping your cluster, and if you want to configure underlying resource, say a GPU, you can do that. This API is really driven and inspired by the persistent volume API. So very clean, you create an API, you request a resource, you have a claim, and that claim is the one that you use in your manifest to really request it. This was introduced in 126, alpha in that version, beta in 132, which just got released, and in a future version is going to go actually final. So that's the way to look at it. But again, if that's an area that matters to you, I would say get engaged. Let's take a look at it from the ML engineer perspective. What are we looking at it from the ML engineer perspective? KubeFlow is a project that has been into existence for a while. And what it gives you is the ability to streamline your AI workloads, simple, portable, and scalable. And that's what the KubeFlow project is about. And essentially, if you think about it, it has all the tools that you need as an ML engineer that you're coming into the cloud-native ecosystem. So if you look at this architecture, at the very bottom is what you see is your hyperscalers, or your private cloud, or your data centers. It doesn't matter. And that is unified by a common compute layer of Kubernetes. And once you have that common compute layer, on top of that is where you see all the tools that you would expect as an ML engineer. Whether it's hyperparameter optimization, whether it's training, whether it's inferencing, there is a corresponding project within KubeFlow that gives you that ability to make a difference. And then on top of that, essentially, all your frameworks, whether you want to program in PyTorch or TensorFlow, you can play around with that. So as a developer, you really focus on your PyTorch functionality and let KubeFlow do all the heavy lift. Another project worth mentioning over here, which I believe Aparna also mentioned, is Q. And that really manages your ML batch workloads. So those are some of the projects, if you're coming in from the ML perspective, are very relevant. And the last perspective that I want to share is from an app developer perspective. You are an application developer. You build a Java application or a Go application. All you just want to do is, I just want to build a GenAI application. My boss is saying, incorporate GenAI into my entire workflow. How do I start? For that, there's a new project in Linux Foundation called as OPEA, Open Platform for Enterprise AI. And it basically gives you GenAI blueprints for cloud native. Take a look at opea.dev, and that gives you those ready-made blueprints. Let me talk a little bit more about that. As you are building a typical GenAI recipe, you're looking at multiple components. You're looking at embedding. What kind of embedding model I need to choose? What kind of retriever? What kind of re-ranker I need to choose? What is my vector database is going to be? What is my LLM going to be? Is it going to be LLM? Is it going to be SLM? Should I download an open source model? Should I use a closed model, which gives me efficiency? Far too many choices that you as a developer has to make in order to compose this GenAI recipe. And if I just pick 3 components where the biggest variation is, from the embedding, lots of choices that I need to make. Again, from a vector database, hey, should I choose Pinecone as a managed service? Or should I use Redis or Milvus or one of those open source databases? Ditto in LLM. Should I use a LLM? Should I use a SLM? Should I use a 1 billion parameter, 5 billion parameter? I'm just an application developer. Since when I need to understand all these intricacies? So this is exactly what OPEA provides. It gives you like a chatbot recipe with all the RAG components incorporated into it as one recipe. And it is a cloud-native recipe. You could deploy this using Docker Compose, or you could deploy this using a Helm chart. Within the OPEA project, there are 20-plus GenAI recipes that are ready to roll. With a single click, you can take any of these recipes, whether it's a chat Q&A, audio Q&A, video Q&A, code translator, code generator, agentic workflows, all of those are available. It has component-level microservices for things like embedding, retriever, re-ranker, LLM, and all of that. And then using those component-level microservices, it creates this GenAI recipe for you, which is a single-click deployment. The project has grown dramatically over the last 8 months, I would say. We started with about 14 launch partners, and there are 50-plus ecosystem partners. If I can highlight some of the partners here, even though the project was originally created by Intel, but AMD is one of the partners, and they have contributed their hardware to the CI/CD pipeline. And what that means is these GenAI recipes are getting validated and optimized for the AMD hardware. Within the CNCF AI ML working group, we have been doing an excellent effort where we are coming up together and validating these samples in addition to Xeon and AMD on ARM architecture. And literally a couple of days ago, there was a pull request sent which says, hey, we need to publish these Docker Hub images for the ARM architecture. So in that sense, you cover the trifecta of the hardware architecture. ArongoDB is a graph database. You don't need a vector database for the backend. Your source of truth could be sitting in a graph database, either ArongoDB or Neo4j, or whatever works for you, really. Infosys has been a great partner. We have been working with them to really incorporate ELK as a backend, so Elasticsearch as a backend, and they've been doing scale testing of it. And in addition, they have also done the work where we're going to publish the OPEA solution on the Azure marketplace. Prediction Guard has contributed guardrails, essentially, that could be contributed over there. So I can just go on and on in terms of the integrations that we are building on. MinIO, a common data layer. Throw any unstructured data in, you can use that for building your GenAI recipe. OPEA solutions work on all major cloud providers, whether on AWS, Microsoft, Azure, Google Cloud, IBM Cloud, or Oracle Cloud. If you scan this QR code, it takes you up there. It gives you a simple recipe. End of the day, all you're doing is you're provisioning a Ubuntu VM. And on that Ubuntu VM, you just install Docker, and you fire it up using Docker Compose. That's the easiest way. It's very easy and quick to go. Or you can install micro-K8s on that, and then download the Helm charts and get it up and running on that. So that's super straightforward. And when we were looking in the CNCF AI ML working group, this was one of the concepts that was coming again and again, that how do we create these kind of recipes, essentially? OPEA solutions are also available on AWS Marketplace. These are basically Terraform-based recipes that are available, again, for very quick deployment. It basically runs, it gives you an opinionated stack. It gives an LLM. In this case, we are using the TGI LLM. We are using an embedding model, a vector database, which is basically OpenSearch, which is the open source database at the back end. And it's a full-on deployment on EKS. And as you know, EKS is a fully upstream compatible. It's fully configurable as well. So if you want to, say, do the integration with Amazon Bedrock, there is a component for that. And what that gives you is the ability to choose your backend LLM. By default, we do the integration with Anthropic Cloud 3 Haiku, but you can bring your own LLM to Bedrock and then do the integration over here. Guardrails are there, or you can use Redis as a vector database. Let's bring it back together here again. This is the landscape, CNCF landscape that you have seen across the presentations. This one is particularly targeted for cloud-native AI. So if you are starting your journey on cloud-native AI, this is a place, could be your first place that you can take a look at it. Okay, I want to understand what's going on in the space. I want to get an overview. So scan this QR code. This is available on the landscape.cncf.io. Otherwise, get a feel for it. So let's bring it back together here again. As we talked about, cloud native and AI are really meant to be better together. The cloud native platform has evolved over the years in terms of supporting these different kind of workloads, and AI is just another workload. Will continue to evolve. I'm really excited about the next 10 years that is there in the future. Some of the upcoming white papers from the AI working group are on AI scheduling challenges, AI security, and sustainability. And that working group really needs your help. I think this is a great area, whether you're coming from the cloud native side or the AI side. I think that contribution could really benefit a long way, not just the working group, but to the broader community as well. Get your name there in the white paper. And the last thing that we're looking from help is, one of the concepts in the working group we have talked about is the AI playground. where we can create a playground where cloud native and AI services could be offered as on top of cloud native. And that's where we have been validating OPEA samples on ARM architecture using Oracle credits. So all you need to do is volunteer. We give you the infrastructure. We provide you the credits on ARM architecture and get us rolling on that. Thank you very much.